And the penultimate set of questions commences with question 19. A Fibonacci sequence begins 0, 1, 1, 2, 3, 5. So a Fibonacci sequence is one where you add the preceding two terms to generate your next term. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, and so on. Or slightly more formally, un, the nth term, is equal to un minus 1 plus un minus 2. That is, if n is 8, for example, u8 is equal to u7 plus u6. Add the preceding two terms. But here you're just asked for the 8th number and the 11th number in the sequence, so we may as well just continue onwards. 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 13 plus 8 is 21. I should really number these terms: 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. The 8th is 13, so this is a 9th, I need two more. 13 plus 21 is 34, and 21 plus 34 is 55. So you have your two solutions. Question 20, solve the simultaneous equations, and then you're given some formatting advice here so that you can get full marks. And you need, crucially, to pair up these solutions. That's basically what it's telling you here. So whenever you have a quadratic simultaneous set of equations, I would always suggest eliminating the variable that isn't quadratic. They've made that nice and easy for you here, because if y is equal to 9 minus x and y is equal to 2x squared plus 4x plus 6, then 9 minus x must equal 2x squared plus 4x plus 6. That's just me writing y equals y. So I have a quadratic equation to solve. It's in one variable. I need to make my quadratic equation equal to 0, therefore, in order to solve it. So I'm going to add x to both sides and subtract 9 from both sides. 2x squared plus 5x minus 3 is equal to 0. And then I can factorise. So I have 2x and x. That's the only way I can get my 2x squared. Equally, I have 3 and 1. One of them is going to be negative, one's going to be positive. So 3 times 2 is 6. 6 and 1 I can combine to get my plus 5. So I'm going to add 3 and subtract 1. I get 2x squared minus x plus 6x, so plus 5x minus 3. And therefore x is equal to a half, because 2x minus 1 equals 0, or x is equal to minus 3, because x plus 3 equals 0. In either case, I need to find the corresponding y value. So when x is equal to a half, y is equal to 9 minus a half, which is 8.5, or because I'm writing in fractions, 17 over 2. And when x is minus 3, y is equal to 9 minus minus 3, y is equal to 12. Now they've asked you to write them as separate pairs, and they will in the real exam too. So I would write them, therefore, in the exam as x equals a half, y equals 17 over 2, x equals minus 3, y equals 12. Making sure it's very clear which is paired with which. Sometimes you can write them as coordinates, not in this question here because of the software, but they would permit that in the exam. Question 21 asks you to complete the table of values for this reciprocal function. Y is 6 over x. So if x is 0.5, 6 divided by 0.5 is 12. That's just how many times does a half go into 6. If x is 3, 6 divided by 3 is 2. If x is 4, 6 divided by 4 is 1.5. And if x is 6, 6 divided by 6 is 1. Nice and straightforward. Part B, which of A, B or C is the correct curve for y is equal to 6 over x? So I'm just going to check some coordinates effectively. So 0.5 has to go through 12. Not happening there. Is happening there. Is happening there. X is 6, y should be 1. 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 Only one of those graphs has those coordinates match, which is C. Just as a bit of logic, they're almost certainly going to make you rely on a value you've calculated to work these things out. That's why I started at the extremes. That's most likely where they'll make changes. And with that, the penultimate trio is sorted.